everybody. How is it going? It's I guess we're about a good chunk of the way through I/O. So it's time to talk about security stuff.
I have a security question for you.
Oh, you do?
Can you type your password, please?
I can. You should never do this.
Thank you kindly.
The demo effect. It is already upon us. Before we've even started. So we're going to be talking about securing your apps and user data with Google Cloud, just like the title says. And it is I/O, so I get to talk about my favorite part of I/O, which is all of the really cool applications that all of you are building. It's my favorite part, is kind of meandering around through the crowd and talking about the challenges and excitement that you're all encountering. Some people are writing applications about travel or finance. Other people are writing applications about staying safe on bicycles. And it's this variation in software that makes all of our apps special. It's kind of the reason we write them anyway. And this means that it is very difficult for us to give you an overall talk about security that is perfectly fit for all of your needs. Because just like your applications have things that are special about them, the security needs you have are also going to be often very specific to the solutions you're working on and the technology used to implement them. But we need to talk about something. So we are going to talk about security on an application that we have developed in hopes that you can apply some of this information to the applications that you work on. And that application is Add a Cat to That. The way this application works is you take an awesome photo, like this photo I took in San Francisco a couple of weeks ago. I think it's pretty nice already, the Painted Ladies. It's a neat landmark.
Could we make it better?
We might be able to make it better, because that is the next step. You take that photo, you send it up to the cloud. And in the cloud, we do sophisticated artificial intelligence and send that photo back to you improved. Because everyone knows that the internet benefits from more cats.
Could we make it even better?
Oh, yes, we can make it even better, because it does support recursive submission of the photos. The photo that comes out, you can send it back to Add a Cat to That and add as many cats as you want by submitting it over and over again. And then once it's ready, once you've reached sufficient cat load, you can upload it to your favorite photo sharing site. And you are good to go and properly paying homage to the true nature of the internet. So let's take a quick look at our application in action. So if we could go to the demo. Oh, do you want to switch to the web browser?
Sure.
We're revealing the code. Oh, here it is. Here's Add a Cat to That in our wonderful mobile-first interface. We're going to submit one of my favorite pictures of cake, because food photos are the other half of the internet. We'll add a caption so that everyone knows what we think of the photo, and our photo is improved. Yay! But this is a developer conference. You're not here just to see our interface. So let's take a look at the code and see how we've implemented this. Here is the truth about Add a Cat to That. We're not doing any sophisticated machine learning yet, because this is our MVP, our minimum viable product, just enough to go out and try and raise some money. It's actually a very short Python program, about 20 lines of code, implemented using a micro framework called Flask. And all it really does is the photo gets posted up, and then we fork off a subprocess to a common image manipulation program called ImageMagick, take the results, and send it back to our users. And this is pretty easy to get together. Then we had to think about how we're going to run the software. This is a greenfield application, like we're starting from scratch, so we had the opportunity to take advantage of a lot of the new, cool development techniques. And that's where Docker came in, so that we can enable fast development environment creation and easy deployment to production. We packaged it all up in a Docker file, which was a snap. We went to Docker, got the Hello World tutorial, and just changed it so that the Python 3.7 base image is now uploading, or now combining all of the files for our application and then running it in Unicorn, a Flask runner. Cool. So with that, let's go. Oh, wait, one more thing. We want to look and see how we're running it in production.
Yep.
So we're going to go on over to the console. Since we are also using a Docker container, not only do we get the benefits of a really easy development environment to kick up, But we also have a whole bunch of places that we can almost click a button and run it in production. And at the current stage of add a cat to that, we are using the beta Cloud Run, which we made available a few weeks back. And it's a really great fit for us. We uploaded the image, used Cloud Build, and it was pretty much turnkey, appointed our domain name at it, and we were ready to start pitching our application for the next round of funding. But this is when the next question came up, which, if we can go back to the slides. Boop. This is when the question of security finally started to come up. We're going around, we're talking to potential investors, and we're getting this question over and over again. Everyone wants to know if our application is secure.
Is it secure?
That's a little more complicated. I guess we'll be getting into that with most of the session. Over and over again, we heard horror stories of people's previous investments ending up in the headlines. But the truth is, security is not really a binary thing. It's not a yes or no question. You don't just flip a switch and suddenly your application is secure. It's much more complex than that. A little fuzzy, maybe even like a kind of a gradient is another way of thinking about it. To work towards a more secure application, to move further along that spectrum, we need to do some work. We need to put on our attacker hat and do an exercise called threat modeling. In threat modeling, what you do is you take advantage of the fact that you are probably the best person to attack your software since you know everything about it, or most of the things. And then you use what you learn from that process to make your application safer. One of the foundations of this technique is that a hacker's probably not just going to randomly hack at your software. Well, they might, but probably not. They're probably after something specific. They probably have a goal in mind. This might be your user data. This might be financial information that you have in a database. Or the truth is the goal could actually be outside your organization. They might be using you as a stepping stone to get at something else. Like they might want to take advantage of an open source library you maintain that other people use. But they won't be able to get straight at that goal. Because it's important to you, it's probably pretty well protected. So an attacker is going to look for intermediate resources. They're going to investigate your environment and try and find different things that they can take advantage of to pivot and move around and make it further into your system. These intermediate resources could be things like servers running in a cluster, but they could also be things like libraries you depend on or even your developers themselves. And as they investigate, they're also going to try and learn about any defensive measures you have in place. Anything from password policies to auditing you do to firewall rules and the like. They're probably going to start the process of enumerating all of these things from information they can publicly find online, like photos from your last company party that made it up to LinkedIn somehow. And maybe they'll get a foothold in at some point, and they'll spend time very carefully and gradually enumerating all of those intermediate resources and all of those defensive measures you have in place, until they find a way to string them all together to wiggle around the defensive measures you have in place and strike at that goal and get access to that information or plant that malware or whatever they want to do. And this is called a kill chain. This part can happen very quickly. But what we want to do is we want to defend against those threats. And our first impulse might be, after doing some threat modeling and figuring out a kill chain that someone might be able to do, would be to take one of our defensive measures and just beef it up. More firewall rules, more broken down network, that kind of stuff. But that's not always the best investment of your time. Going straight to our pet solutions is not always the best thing we can do. It turns out that often a better use of your time is to focus on removing unnecessary things that could potentially be intermediate resources, and of the ones that you need to keep, reducing the attack surface to make them smaller. And in addition to that, rather than have one strong defensive measure in place in a certain area, it's more effective to have a greater number of easier to maintain defensive measures that overlap, so that if one fails, another one might get triggered. And this technique is called defense in depth. so that if one thing fails for whatever reason, you have another backup behind it to help protect you. And this is a philosophy that we believe in very strongly at Google. So we all have multiple different things we want to protect. Today, we're going to be talking about a few different things that you can do to establish that defense in depth. We're going to be talking about secure supply chain, which is about making sure you don't deploy bad code that someone else wrote or deploy dependencies that might have problems that we already know about. We're going to talk about automatic vulnerability scanning so that we can find that low-hanging fruit, those silly mistakes we make that we kick ourselves when we find before someone else finds them for us. And we're going to talk about the nut behind the wheel, another potential weakness, making sure that phishing does not cause us a problem. Because phishing is something that we often joke about and we tease people, but it's a surprisingly effective technique in offensive security, despite the fact that we're all immune to phishing, obviously. Surprisingly not. So first, let's dig into one of those deeper. Let's talk about secure supply chain in the context of add a cat to that. So add a cat to that is a very short program. Like you saw, it has like a dozen lines of code that's kind of the core functionality. But believe it or not, it has hundreds of dependencies. And this is one of the things that made it so easy to write add a cat to that is we all kind of stand on the shoulders of giants. We get to include a lot of other people's work to get started very quickly and make very rapid progress as developers. But some of those things we depend on might be neglected, or someone else might have made a mistake. So that's a really large surface for things to potentially go wrong. And we don't want to be sad. And in fact, we can kind of get an idea of how big this risk is. In 2018, there were over 16,000 published vulnerabilities, called CVEs, in vulnerability databases. And that's way too many to keep track of manually. So if we tried to subscribe to newsletters and then kind of investigate, add a cat to that each time to see if we're impacted, we're never going to be able to keep up. But we're software developers, and when we encounter a problem like that, we solve it with software. And fortunately, we are using Google Container Registry to store our container images before we push them to production and Cloud Run. And I'd like to show you a feature of that can help us keep our supply chain secure. So with that, let's go back to the demo. So here is the container registry, where all of the add a cat to that images are published. And if we go over to the settings pane of container registry, we will see a feature that is normally off by default. It is a beta feature, but it is awesome. It is worth checking, even if you're a little bit beta skittish. We've already enabled it ahead of time. It's called vulnerability scanning. And now if we go back to our list of images and go into our web application image, you will see a new column has appeared on the far side. And if we click into that, we will see that our image, which only has a few dependencies, or so we thought, and a dozen lines of actual code, has over 600 vulnerabilities and only 38 fixes. That's 6 or 7% that even can be fixed. So it's at this point that a lot of people might start to panic. But don't panic. It's OK. It's better that we know about these early on, right?
How are we going to solve 600 vulnerabilities?
Well, first, let's investigate if any of them are actually relevant to us. Because these vulnerabilities are related to the dependencies we use, but they might not actually impact the way we use our application. So let's click in on one of the ImageMagick ones, because that's one of the things we use. And here you'll find details on exactly what it is. This one is an uninitialized variable leading to memory corruption. So if we wanted to, we could dig through the potential use cases. We could do threat modeling. We could dig through all the use cases that a cat to that does and see if this is even relevant to us. And even if there's not a fix, we might be able to set up, we might be able to do defense in depth and set up a secondary measure that protects us from this particular issue. Although this one looks kind of bad. So let's see if we can come up with a different way to mitigate this issue. So for that, let's look at an experiment we ran. So if we go back to the code, we did an experiment. Well, first of all, when we looked at all of our potential vulnerabilities, we noticed that a whole bunch of them are related to image magic. Image magic is wonderful. It is super fast, but it is also very complicated and has a lot of vulnerabilities that get discovered in it as a result. So we discovered that there is a pure Python implementation we can do to implement the exact same functionality. It's a Python library called Pillow. And with just a few lines of code change, we were able to re-implement, add a cat to that, and remove the forked image magic process from it, which was a huge win. Another thing we did was we tweaked our Docker file a little bit. As much as the Hello World Python 3.7 image got us started fast, it turns out it had a whole bunch of stuff in it that we didn't need at all, which were well represented in that vulnerability list. So we went and grabbed a slimmed down base image. And there's a lot of these available. We chose Alpine Linux for this one. And we had to do a little more work here. We had to explicitly install all of our real dependencies. But other than that, the Docker file is pretty much the same. But with that one little change, boop, we shot it back up to container registry and stuck it in the experimental. And you will notice that if we go over to the vulnerabilities tab, oh, it's right there too. It shows up in the interface a few places. Surprisingly, I thought there would still be some vulnerabilities, but it got it all the way back down to 0 with just a tiny little change. And the truth is that this change did have a cost. It is slower and it uses more memory now. But that is the decision that we have to make. We have to decide if the performance overhead is worth it to this, or if we want to put in other, maybe more complicated or more difficult interventions in place to prevent it. In this case, at least for us, we're at the MVP stage. We just want to show some cool demos and not get pwned in the process. This was a great solution for us. So with that, I guess we're probably ready to go.
I think we're done. Yeah?
Really? Well, I don't know. Why don't you tell us a little bit more?
Let's go back to the slides. So I think everything's secure now, right? Because we've fixed all of the dependency chain, and we just eliminated 600 vulnerabilities in a matter of minutes by making those two changes.
And we review all our code every night.
Especially at 2 in the morning.
Usually at 2 to 3 in the morning.
The night before the demo.
Yeah, after.
So maybe we've made some mistakes. Maybe you all have made some mistakes, and your code is not 100% perfect, because we all introduced some bugs. Well, I also want to tell you about a tool that can help you there. So Google's Web Security Scanner will do automated testing of your deployed code to find those bugs that you've introduced vulnerabilities unintentionally. And rather than tell you all about it, let's just show you. Let's switch to the laptop.
Sure.
So we're going to bring up Cloud Security Scanner once we switch to our demo. And what you can see here is the simple web UI in GCP. Let's make a new scan just to walk through the steps. It's very, very fast. So as we make a new scan, we're going to point this at a staging URL for our app, because this is actually going to be fuzz testing our web app. And you don't want to point that at your production instance, or you're going to be introducing a whole lot of wacky data, and it might corrupt your application. So point it at something in staging or dev. We've put in the Kubernetes pod address there. The rest of these things you can leave as default. I would head down and make this run daily so it can automatically update you when any new issues are found because of a new push. So we're going to save this. It's going to take about 15 minutes or so to actually get going. So let me show you one cat scan that we made earlier, just so you can see what some of that output looks like. Now, our code's totally safe, right? Right?
There's some issues, it looks like. Scanner found stuff.
All right, let's see what the cross-site scripting issues are.
OK, those can be scary.
Yeah, so the web security scanner starts crawling around all the URLs it can find and starts looking for these known vulnerabilities. In this case, it found a cross-site scripting bug in our admin login page. And what it's giving us right here is the exact way to replicate that bug so that we can troubleshoot and then fix it. So we're going to make...
Sure. Let's take a look at the test data it gave us so we can reproduce it. I'm going to drop that into a new file.
So we're going to show you this bug live, and then we're going to fix it right now so that we can knock yet another vulnerability off of add a cat to that. Because we don't want our cats to be insecure. So taking that HTML from Web Security Scanner, we can see here that doesn't look right.
No, it should say the email address of the person who tried to log in, not some weird stuff.
Yeah, that's pretty weird. Let's go to the login page HTML and see if we can fix this.
OK, it's right here.
So this login page, which is called out by the Web Security Scanner, this is where that HTML came from. And yeah, I remember now what happened. Back when we were writing this the first time, we assumed anything submitted to this form was going to be totally safe because it was going to be just coming from inside.
Right, because we wanted people to have email addresses with pictures of
Yeah, now that we're getting ready to launch, maybe we should reconsider that.
Well, that's an easy fix.
Let's take that out.
Remove that.
All right, now we're allowing the cross-site scripting prevention that we had actually disabled before. I'm sorry for the double negative. So we push that fix build to production right now. And the coolest part about this whole process and the tool is that the web security scanner doesn't cost you anything to use. This is free. It's very easy. It's not perfect. Neither is your code. But it's going to catch a lot of those common, easy-to-prevent errors. It's not going to protect you from a sophisticated attack or a new clever zero-day. But it will help you with things that may have slipped past your code review process. Very low friction, and it's fire and forget. Once you set up that daily scan, it's going to keep going. All right, let's go back to the slides. So we have secured our dependency chain by fixing some of those library issues. We've made sure our code is secure. Now we're safe, right? There's no possible way someone could compromise, add a cat to that. Well, what if somebody manages to get into my account or Jen's account with a good phishing attack? All of those previous protections are useless. So I want to talk about the people and how you can secure the people with better authentication. A typical login flow looks something like this. You present your login password to the server, and then you're in. Oh, no. Somebody was actually giving you a very clever phishing page. You've given them your credentials, and now they're logging in and doing anything that you could have done. They could modify your source code. They could add some malware. They could sign a malicious binary with your keys. This is terrible. There's a lot of bad things. But you think, I'm good. I have this one-time password that my phone gives me.
It doesn't always work, though.
Oh, man. So the phisher can just take that one-time password, too, and now they're passing it forward, and they're logging in as you just as successfully. This doesn't actually prevent phishing. So I want to tell you about a better way. These security keys, which you can either get as a USB key or Bluetooth, and now you can actually use your Android phone, thanks to an announcement a few weeks ago from Google. These will do a much stronger second factor to make your login secure. So I want to replay that previous scenario in a way that's going to stop phishing in its tracks. Instead of being complete, after you give login name and password, the server replies with a challenge. It knows that you registered a security key onto your account already, and it has the public encryption key for that security key. So you get that challenge back, and your security key, when you tap it, is actually verifying the domain that it's talking to. That means a phishing domain, even a very cleverly disguised one with a URL that looks almost exactly the same, except for that weird ASCII character that's using that's not really an O, but looks like an O, won't work. The key won't sign that challenge and return if the domain isn't exactly what it was set up with. If the domain checks out, your security key signs it, returns the challenge. Now, the server can validate that you used a key that it expected, that you already registered in the past, so it knows that you not only possess your password, but you also possess that key. Something you know, something you have. Now you've authenticated in a way that's extremely resistant to phishing. We've been using this a lot at Google, and it's really effective. Let's switch to the demo. I'm going to show you how it works. So, Jen, why don't you log in?
Look it up.
Here's your account. Put in the password. And now it's going to ask for one more step. Security key. We'll plug that in, give it a tap. All right, we are in. Now, Jen's a super admin on this domain. We definitely want to protect those accounts. It's really, really important. So I would recommend that you use security keys for everyone. That's not practical in all circumstances. So let's say you want to set it up just for your engineering team. Let's go into the security settings in our Google admin. And we're going to go look at our basic settings and get into the advanced two-factor, two-step security settings. From here, we can choose what kind of enforcement. Let's turn on two-factor for end of May. But actually, we also want to make sure that we're doing this for people where it really matters. So we can set it up just for the engineering group.
Right, we can probably get them keys in time.
The whole two-person engineering team.
Exactly.
Perfect. So we can select the engineering team right here. And now we can say, turn on enforcement for the end of May. And you can decide what kinds of two-step authentication you're going to allow. I think we only want security keys, because as we just learned, an OTP is just as phishable as a password. And as soon as we save this, we're set. It's as easy as that. All right, let's go back to the slides. So we've had you here for a little while. We've been working on add a cat to that. What do you think? Have we made it more secure? Yeah? Are we done? No? Well, let's review what we have done. We've secured our supply chain with the Google Container Registry and scanned to find some dependencies that we needed to remove. We have looked at our own code and our web app to find some cross-site scripting vulnerabilities that we could also fix. And we've added stronger authentication for our engineering team, so it's much harder for someone malicious to take over one of our accounts. But you're not all making add a cat to that. At least I hope not, because if you are, I have a lawyer who needs to talk to you. Your software is different than ours. And that means the threats you face are going to be different than what we're looking at. And what's important to you might not be as important to us. You need to have your own security strategy. So this is the beginning. And I hope that you'll explore some of the security features, Google Cloud, or the other platforms that you're using. And I hope that you'll do a little bit of exploration of the documentation. I also want you to do some threat modeling. Put on that attacker hat. Figure out what someone who knows a lot about your application could do if they were feeling especially nasty. This is the start of your journey, but it's just the beginning. Thank you very much for joining us.